Hello everyone, this is Cece Heinen from the Minnesota Daily, and you are listening to In the Know, a podcast dedicated to the University of Minnesota. Today's episode is a bit more lengthy and serious, and maybe personal for some listeners. I was inspired to write this episode after I opened Instagram on September 23rd and found out that Zuza Baina passed away. For those of you who don't recognize her name, she was a 14-year-old girl from Wisconsin who lost her battle to acute myeloid leukemia, or AML. She was diagnosed with AML when she was 3. Baina bravely documented and shared her cancer journey to more than 5 million followers on TikTok and Instagram, which is where I found her. I had been following her for about 2 years and was deeply inspired by her relentless positivity and joy in the face of cancer. Zuza's passing made me want to know more about how the University of Minnesota is researching and developing treatments for cancer. I know many of you may hear the word cancer and immediately feel a sense of dread, because it's such a notorious disease. Like me, you may also not be a STEM major and struggle to understand the complex science that goes into treating cancer. To help answer questions about what the U of M is doing in the field of cancer research and how they're doing it, I spoke with 5 cancer researchers who each work in different realms of the disease. First, I spoke with Brandon Moriarty and Bo Weber, who are both associate professors in the Division of Pediatric Hematology and Oncology and earned their doctorate degrees here at the U. They co-run a lab that focuses on gene and cell therapy for both cancer immunotherapy and correction of genetic disorders. What is cell and gene therapy and immunotherapy, you may ask? Let me hand it over to the professionals to answer that.
We have the cancer side of things and then these rare genetic diseases. And I think on the rare genetic diseases side, it's really advancements in our ability to change the genetic code of cells, particularly with the development of CRISPR-Cas9 technology. And so these kids are born usually with a single mutation in their genetic code. One letter of the code is wrong. And so now with these new CRISPR enzymes, we can very efficiently deliver them into cells where they can correct that single base or letter mutation, thereby correcting the entire disease in some cases. On the cancer side of things, it's really the develop of what we call immunotherapies. So it's become apparent that the immune system is critical to identifying and eradicating cancer. And so we and many other in the field have been spending a lot of time and energy developing therapies surrounding our ability to modulate an immune system, whether that's taking out a patient's immune cells, engineering them, again with CRISPR to make them better, faster, stronger, and then reinfusing them in the patient, or by developing drugs or small molecules that we can give to the patient, whereby in the patient's own body, it will actually retrain immune cells and activate them such that they're potent against the tumor that's in that patient.
CRISPR, which was originally discovered in nature, is now used across the world to discover cancer genes, create cancer therapies, and correct genetic mutations. CRISPR has become a vital tool for cancer researchers who are leaning into the immunotherapy response to cancer. David Largaspada, the Deputy Director of the Masonic Cancer Center and a professor in pediatric hematology and oncology, runs his own lab in Moose Tower that researches similar immunotherapies. His lab focuses on a particular cancer predisposition syndrome called neurofibromatosis type 1, or NF1.
Most people haven't heard of this disease, even though it affects about 1 in 2,500 people. It is an inherited disease, but half of all cases are a so-called de novo case, meaning the affected child is the first in their family to have it. And what we're doing is studying the tumors associated with NF1, and in particular, these patients are predisposed to brain and nerve tumors, and trying to find vulnerabilities that we can exploit therapeutically. So think of it this way. Tumor cells are sort of like supervillains, but like any supervillain, they have their hidden weakness. So for the Wicked Witch of the West, it's water. For these tumor cells, we're figuring out what's their Achilles heel, what's the one thing that they're sensitive to do. And we're doing that using drug screens and genetic screens. Find out what genes are they reliant on that normal cells wouldn't be reliant on.
Another researcher who is working on coding genetics to better fight cancer is Paolo Provenzano, a tenured professor in the biomedical engineering department. His lab researches how patterns in tumors influence how cells spread and metastasize or move through the body. His lab works to engineer immune cells to be better cancer fighters and function more efficiently in solid tumor environments. Provenzano was drawn to cancer research because of a deep passion for beating a disease that he lost many loved ones to.
I'm a bit of an anomaly in a not great way, which is I've had a really disproportionate number of people in my life die from cancer. And that list includes my father, two of my uncles, and a cousin, my postdoctoral mentor, and one of my best high school friends. I also have other people in my life who've battled cancer. It started my initial thoughts on transitioning into cancer research, and ultimately what led me to doing a postdoctoral fellowship at the University of Wisconsin in cell and molecular cancer biology with the late Patricia Keeley was that one of my close friends in high school died of cancer. It was also the same kind of cancer that my uncle had died from. And so those were both liquid tumors, and both of those got under my skin quite a bit, just really bothered me. And I really felt like that was a direction where I was scientifically interested, but really just kind of wanted to push back and make an impact and kind of fight back.
Provenzano has been running his own lab for 15 years and continues to make strides towards more sustainable treatments for cancer. The last researcher I spoke with was Dr. Melissa Geller, a gynecological oncologist in the Department of Obstetrics, Gynecology, and Women's Health. Dr. Geller started her career thinking she wanted to be an OBGYN, but eventually made her way into working on ovarian cancer.
And then I did OBGYN and fell in love with the patient population. And at that point, really thought I was going to want to do OB and deliver babies. But again, the surgical part of that really drew me in. So I did my residency in OBGYN, then decided to stay on for a fellowship. So did an additional 3 years to become a gynecological oncologist. I think the ovarian cancer population is really what drew me to that, just because these women were amazing patients and the disease was so terrible and really heartbreaking as it affects women in the prime of their life in their early 60s. Unfortunately, tough disease to treat. And so that's really what kind of guided me towards focusing my work on ovarian cancer.
All 5 of these researchers work with different cancer types and are striving towards different treatments. This diversity within the disease is what makes cancer such a difficult disease to cure. Larga Spada and Provenzano said cancer cannot be categorized as just one disease because of the immense number of variations.
Cancer is a difficult problem because it's really more than one disease. So each form of cancer is different. And even when someone's diagnosed with the same cancer, their case may be unique. Just as an example, one of the most common forms of cancer is breast cancer. But actually, not all breast cancer is the same. There's at least 5 major types. And depending on what type you have, the therapy will be different. And so it's a hard problem for us because there's really many different diseases.
Two biggest things are the massive heterogeneity of it. So each cancer is very different and needs different kinds of therapies to intervene. And then even within a certain cancer, there's just a massive amount of heterogeneity. So the underlying genetic abnormalities that are driving it are not the same, even if, like, say, a breast tumor, a brain tumor, a lung tumor, they're vastly different versions of each of those tumors. So there's not a one-size-fits-all solution to even a single type of cancer, let alone the other ones. The other big hurdle is that it's a disease that evolves. It continues to change and adapt and become resistant to therapies, has already evolved, before we detected it, a number of ways to be resistant to therapies. And then once we start insulting it and giving it stresses from these therapies, it adapts.
According to the National Cancer Institute, roughly 2 million people will be diagnosed with cancer in the United States in 2025. Breast cancer is the most common diagnosis, followed by prostate cancer, then lung and bronchus cancer. As Larga Spada and Provenzano just said, all of these cancers have multiple different variations within them, which makes them much more difficult to treat. Dr. Geller's research is centered around ovarian cancer, which, along with breast cancer, affects women and those with female reproductive systems. She recounted a meeting she attended with the American Gynecological Oncology Society, where people from the National Institutes of Health and the National Cancer Institute spoke about how only 9% of all research funding goes to women's health.
And so it's such a small proportion of the dollars that are given for research that have really focused on women's health. Just to see those numbers up there, and we've all realized it, even just menopausal issues now or perimenopausal issues, it's so understudied because nobody's put any money into it. And endometrial cancer, if you look at the number of deaths from endometrial cancer are rising. The number of women that die from endometrial cancer is even higher than that in ovarian cancer now because it's just been so underfunded.
Dr. Geller has been lucky to receive funding from the Department of Defense for her research on ovarian cancer, which brings us to the meat of this episode. I know what you're thinking. Cece, we're already like 10 minutes in. What do you mean the meat of the episode? What I mean is now you have to lock in and listen to these researchers explain what they are working on in their labs. Pay attention to this part because the work these scientists are doing in their labs is truly remarkable. Let's start with Dr. Geller, who, as I said, is working on treatments for ovarian cancer, starting with something called a natural killer or NK cell.
So natural killer cells are kind of our first line of defense. You get a sliver in your finger or you get an infection, NK cells are able to go in and attack those foreign bodies. We've kind of been trying to transition those into solid tumors, like ovarian cancer. And that's kind of where I've come into play for many years, is trying to determine how we can manipulate these natural killer cells so that they work better against solid tumors. These cancers, when they develop in patients, they tend to spread throughout the peritoneal cavity or inside the abdomen. It's kind of like having sprinkles of Rice Krispies being spread throughout the abdomen, on the bowel and the peritoneal surfaces of the abdomen. That environment within the peritoneal cavity is really immunosuppressive and difficult to treat because the tumor tricks the immune system into hiding itself. So it's just such a terrible milieu that you can't get any immune cells to work against it. What we've been trying to do in the lab is trying to figure out how we can, number one, deliver natural killer cells directly to the peritoneal cavity, as well as to manipulate those NK cells so they kill better.
In the next 5 years, Dr. Geller's ultimate goal is to be able to bring her lab's new biomedical device into clinical trials. She hopes that this device can help patients with ovarian and endometrial cancer. Larga Spada's lab works with mainly the NF1 gene, and they recently have undertaken projects surrounding the benefits of naturally occurring chemicals, such as curcumin, typically found in turmeric, and olive oil.
NF1 patients also get these benign tumors, neurofibromas. And one possibility is actually a nutraceutical intervention. And a physician came to us with this idea of combining curcumin and extra virgin olive oil. And we tried it in a tissue culture dish and in mice, and it was bioactive. And so she and another physician have done a clinical trial on NF1 patients with curcumin and olive oil. It seems like it's relieving some of their symptoms, in particular the pruritus or itching and headache that these patients can get. It's too soon to say whether it will help slow the growth of the benign tumors that these patients have, but it was a completely new idea for my lab, but we decided to work on it. Some of these foodstuffs actually have beneficial chemicals that have almost like pharmaceutical properties. We can just figure out how to use them properly. So curcumin's one, and then it turns out that the high phenolic compounds in olive oil, an example of which is oleocanthal, can have biological effects. And some of them might be really useful in the context of chronic disease.
If you are inspired to start taking shots of olive oil after hearing this episode, just make sure it's the high phenolic extra virgin kind. Larga Spada is hoping to begin testing the curcumin and olive oil combo in a mouse model within the year. He hopes that it will slow the growth of NF1-associated tumors in mice, which means it could eventually be upgraded to a human trial. Many people may be wondering why labs have to use mice for testing. Why can't they just simulate it on a computer? Well, frankly, the technology is not there yet, and mice offer the closest alternative to human cells.
And we have to use a living animal to study the function of the immune system and the interaction between the immune system and tumor cells. Some of it we can study in a tissue culture dish and not use animals, and we do that. But when we need to find out whether a new immunotherapy could really work in a living organism, we have to use a laboratory mouse. I do think a day will come in the future when we understand biology well enough to just model it on a computer. But at present, when we do a clinical trial for a new cancer treatment, we have to make sure that we're taking the best possible shot we can. These clinical trials are super expensive and super time consuming, and we're asking someone to participate in a study and put their life on the line. And so we have to have the best possible idea that the therapy is actually likely to work and benefit the patient.
Provenzano's lab is working to develop more advanced immunotherapies, which, as he explains, can fight through the decathlon-like nature of a cancerous tumor.
And we spend a lot of time focusing on how do we make them function better in these solid tumor environments. The analogy we often use is the tumor is more like a decathlon than a single event. The cell has to squeeze through a space and climb over something and get there and avoid a few other people and then obviously get to its target and function. And so I think there's a place to thinking about how do we engineer cells that could handle those barriers the best or work as teams. And so when we're thinking of immune system, we're thinking about taking those cells out and engineering them to come back into the body to fight the cancer in a much more effective way. But now we're starting to get a much better understanding of the barriers they face to their effective function and trying to come up with engineering solutions so that they can get where they need to go and they can function when they get there. There's a lot of cancers, and this goes to that heterogeneity thing, where different types of immune therapy may be more or less effective. But for the ones we're studying, I believe cell-based therapeutics are likely to be the most impactful.
Provenzano's lab just finished their preclinical testing on a treatment for pancreatic cancer, which takes T cells out of the body, re-engineers them so they can recognize the cancer, and then puts them back in the body to fight the tumor. They are hoping to move towards a clinical trial phase for this physically optimized T cell within the year. Moriarty and Weber's lab also studies immunotherapies and cell optimization. One example of a current project they just ran through clinical trials is on tumor-infiltrating lymphocytes, or TIL cells.
We were working on developing therapies for essentially these late-stage incurable cancers. We were really interested in a specific type of immune cell that lives within a tumor that knows it's not supposed to be there, but is not able to win the battle. And so these are T cells, and because they're in the tumor, we call them tumor-infiltrating lymphocytes, or TIL. And so other groups had shown that it was possible to take these TIL out of the tumor and grow them up to really large numbers and then put them back into a patient. And in some cases, they would see these remarkable cures of these patients with advanced disease, but it was infrequent and needs improvement. And so we came up with essentially, could we utilize CRISPR engineering to manipulate the DNA of these TIL or T cells to better equip them to find and kill cancer cells? And so we essentially worked to make sure that we could deliver CRISPR reagents to these TIL, that we could target this gene with CRISPR and break it. And then once we showed we could do that, then we did the studies to show that the T cells were actually better killers of cancer cells.
Moriarty and Weber are currently running an initiative called the Minnesota TIL Alliance, or Until It's Cured, to raise money for a second clinical trial for these TIL cells. They hope to apply them to a broader range of cancers, such as breast cancer, ovarian, and sarcoma. Moriarty and Weber are taking funding into their own hands with the Until It's Cured initiative, as funding is becoming more and more unpredictable. All of these researchers rely on multiple different organizations and sources of funding, the majority of which comes from federal programs like the National Institute of Health and the Department of Defense. Dr. Geller spoke about how her lab's funding from the DoD is becoming less reliable.
Funding is difficult, especially in this current situation with the current administration. I've been very fortunate, and my colleagues, my team has been fortunate to receive Department of Defense funding over the last multiple years. And that funding has gone from like $47 million to $15 million this year. So we just put in a DoD grant the end of last month, and the chances of getting that are going to be really slim. The field, is booming, but the dollars are just not there. So the fact that they cut that research for ovarian cancer is really going to affect, again, or put us behind in terms of research for ovarian cancer.
Larga Spada also talked about the effects of funding cuts. He said that there are proposals being considered in Washington to issue a 37% cut to NIH funding, which would be detrimental to cancer research. Funding is absolutely necessary to further development of cancer treatments. Provenzano sits on the NIH grant evaluation team, so he has a backstage look at grant approvals and describes how vital this funding is.
I've worked with the NIH for almost 15 plus years in many capacities. I can tell you that when you get these piles of grants to review them, at least 25-30% of them are really great stuff and probably should be funded. And in a good year, we're funding about 12-13, so about half at least of what really should be funded to move the dial forward. I tell people all the time, I've worked with people on both sides of the aisle at different times. Cancer doesn't care how you vote. Cancer doesn't care which part of this country you come from. It's every one of us problem. It's not a partisan issue. It's a person issue. Nobody wants to see their loved ones die of cancer. I can tell you I've held loved ones as they died of cancer, and it's not something you want to do. One of my colleagues said it really well a few years ago, like our job should be to try to make miracles happen. I think we work really hard on that. It seldom happens. It's really hard, right? Occasionally you get one or two, right? Occasionally you do. But if you don't take those shots on goal, you don't work for it, you don't get those miracles. And so we need to invest in this so that we can someday have more and more and more miracles.
All 5 of these researchers are in the pursuit of miracles. And as they said, funding is vital to making these miracles happen. If you are interested in getting more involved in the cancer research efforts at the U, there are plenty of opportunities. You can visit the Until It's Cured website to support Weber and Moriarty's work towards amplifying the power of T cells. You can visit the Masonic Cancer Center website to learn more about how to support their efforts. And most importantly, you can reach out to your local lawmakers to advocate against funding cuts at the NIH and DoD. Thank you to everyone who listened to this whole episode. If you have been impacted by cancer in your life, I hope this episode has given you more hope for the future of cancer research and potential treatments. These researchers are doing incredible work that needs to be recognized and invested in. If you have any questions, comments, or concerns, please don't hesitate to reach out at podcasting@mndaily.com. This episode was written and produced by Cece Heinen. Thank you so much for tuning in. My name is Cece Heinen, and this has been In the Know.